Okay, so by the end of this video, you should have a screen like this. All I'm really going to show you how to do is to draw this square, and notionally we're going to divide this space up into grid cells of this size in preparation for moving this thing in increments of that cell size. So at the moment nothing happens when I press my keys, but I'll just talk you through the code quickly that gets this up on the screen. Get rid of that. We create let's look at the order of execution. We import some stuff here, create the window, and I have to do this at the top because this function here on draw refers to the window. But then this is a definition of a function, and this is the definition of a function. These don't execute until they're called. So after window equals window 500 is executed, the next line to execute is this, which gives me a notional cell size. I'm going to design this so that I can change this cell size, and we can have a very large world with a very tiny snake in it, or a small world with a big snake in it, and all those things will be configurable. And hopefully by changing some of these parameters, you'll get to see how the code is working. Snake X and Snake Y I've defined as module level variables here, so they should be visible by everyone, and they're going to give me the X and Y coordinates on that window of the top left of where the snake's head, as it were, is going to be drawn. This code here just divides the whole window in width up by the cell size, and makes sure that the top left lands on one of the grid cells. The top left of the snake's head lands on one of the grid cells rather than landing between grid cells. You can try it if you want by doing window width divided by cell size. This double divide here gives you something called floor division or integer division. So if you get a fractional part here, if you were to divide an odd number by 2, for instance, you would get a fractional part, but this type of division here only takes the integer part of the answer. And this little bit at the end here just ensures that the X and Y that we end up with can't be between cells. Like I say, try it with window width divided by cell size without having this bit on the end here, and you'll find that your snake doesn't move in grid cells itself. It actually sort of moves between them, which is not what you're looking for, because you want it to land squarely on top of the food and to be able to run right up to the edge of the screen rather than be half on and half on off the screen and so on. But I'll leave that for you to play around with. Now, this thing window event, Pyglet itself is going to call this onDraw method every time it's updated. So as soon as this screen is drawn here, when we call app.run, Pyglet itself calls this onDraw method, and every time Pyglet does that, all we're going to do is wipe everything off the screen and then draw everything we need to draw, and that's going to happen many times a second. And that's what it's by changing the drawing of things in different places that we're going to get the effect of animation, and that's the same in every game programming platform. So here all we do is clear everything off the screen, and then we call this draw square function. This draw square function didn't exist. It isn't part of Pyglet. I've defined it just to make my life a little bit easier. All it takes as parameters are the X coordinate and the Y coordinate of the square that I want to draw, and the size of the square, which is equal to the cell size. So I just refer to this value here. If I change this to 50, obviously this value is going to be 50, and that will change the size of the square that I draw, and therefore the size of the snake. Let's look at draw square. What it does is it creates an image on the fly. This image.create is built into Pyglet, and you can look at the Pyglet documentation to see exactly what this does. What it wants is it's effectively drawing a rectangle here, and it wants a height and a width. Now my height and width are the same because I'm drawing a square, so I just give it this value size here, which is this cell size that I've been given here. You'll see snake X maps to X, snake Y maps to Y, cell size maps to size, and color is given a default here. And I don't override that default. I could do quite easily if I put in here a different color. Forgive my using the British spelling. I could put something else in here like red, no green, no blue, and that's no transparency, so full opaqueness, a block of color. If I were to run this now, a white square, I've got a red one, and I can change this up as much as I want to, and it gives me 2 to the 24 different values here, because 0 to 255 inclusive is 256 values. That's 2 to the 8, and you've got 3 of them, so 2 to the 8 times 3 is 2 to the 24. Okay, so that's all it does. I erase everything and draw it again, and erase everything and draw it again, and just get that. If I get that up on the screen there, that's what's happening here. This is actually being erased and drawn, and erased and drawn, and erased and drawn every time, or at least it will be every time Pyglet updates. So that's the explanation of this code, and we'll move on to the next one in the next video.